Okay, so this is lesson 6-2. Last week on Monday and Tuesday, we were solving by graphing the two lines and then looking for the point where they hit each other. That was our solution. So this is going to be an algebraic method for solving these without graphing, okay? It's still going to be a system of two equations with two variables. So if you look, there's some steps there, 1 through 5. So let me zoom in on that. So the first step is you have to solve one of the equations for one of the variables. And then I think there was a typo on step 2 there. It should say substitute the resulting expression into the other equation. Then you solve for one of the variables. That's step 3. Then step 4, you would plug that solution that you just found in step 3 into one of the two original equations and solve for the other variable. And then number 5 is you would write your solution as an ordered pair, x comma y. And then to check your solution, when you get your solution, the ordered pair x comma y, if you plug that x and y into the original two equations, it should make both of them true at the same time. Okay? So let's try example 1. Okay, so example 1. Well, the first step over there says to solve one of the equations for one of the variables. Well, these equations are already solved for y, both of them. Both of them are solved for one of the variables. So all you have to do on this one is, if y is equal to 3x, you can take that 3x and you can plug it into the other equation where the y is. All right, so if we do that, then our second equation becomes 3x equals x minus 2. All right, so we plugged in 3x for the y in the second equation. Well, when you plug it in, that's really substituting, okay? That's why this is called the substitution method, because we substituted in the 3x from the first equation into the second equation for y. Well, now that second equation, we can solve that for x. So we're going to subtract x on both sides. That leaves us with 3x take away x would be 2x. And that would equal, well, the x's on the right-hand side would cancel out. And then don't forget, when you bring that 2 down, that is a negative 2 right there. So 2x equals negative 2. Then divide both sides by whatever numbers in front of the variable. Those 2's cancel out, make a 1, so we get 1x, or just x is equal to negative 2 divided by 2. That is negative 1. So there's your solution for x. But in these problems, you have to go back, you have to plug that back into one of the two original equations, and then you have to solve for y also. And by the way, you guys, if you guys need to stop me at any time, just unmute your mic and just give me a shout out and I'll stop, okay, if you have a question. All right, so what we have to do now is we have to take that x equals negative 1. And we can take x equals negative 1. And we can plug that in for the x in the top equation. Or we can plug that in for the x in the bottom equation. So we're going to substitute negative 1 in for x. Doesn't matter which one you pick. I'll do the bottom equation, I guess. So the bottom equation is y equals x minus 2. And I'm going to substitute in that negative 1 right there. I'm going to plug that in for x right there. So that's going to look like y equals negative 1 minus 2. Now, I didn't really need to put that negative 1 in parentheses, but that makes it clear what I'm substituting in for x. All right, so then y would equal negative 1, take away 2 more. That would be negative 3. So we get y equals negative 3. So we have x equals -1, and we have y equals -3. If we plug that x and y into the top equation, it will be true. And if we plug that x and y, x equals -1, y equals -3, if we plug those into the second original equation, that equation would also be true. Now it said to write the answer, step 5, I think it said to write the answers as an ordered pair. So if you do that, you would write x is -1, y is -3. So again, that's the x and y value that would make both of these original equations true at the same time. And if we did this problem graphically, this would be the point, like we did last Monday and Tuesday, this would be the point where the two graphs hit each other. All right, well, let's do a couple more of these, and that's the basic idea for today. So let me take a look at these other examples. Let's see. Let's try, I guess we'll do number 2. All right, so number 2. If you look at that carefully, the first step is to solve one of the equations for either x or y. Well, if you look at that, the top equation is already solved for y. So what you can do then is you can take that quantity x plus 1 and you can plug it in for y in the second equation. Okay, so if you do that, the second equation would become 4x plus the quantity x plus 1 equals 6. All right, again, I put what I'm substituting in for y, I put that in parentheses. And in this case, I don't really need the parentheses either, because if there's a 1 in front of those parentheses and there's a 1 up there as the power on that quantity, then I don't need those parentheses. So I'm just going to go ahead and drop them. All right, so now somebody unmute and tell me how to solve this equation for x. What's the first step? I mean, I could call on you guys, or you could just unmute yourself. What would I do to solve that equation for x?
You add the 4x and x?
Yes, that's good. So you take the 4x plus the 1x. So you're going to combine like terms on the left-hand side of the equal sign. So that 4x and that positive 1x right there, those are on the same side of the equal sign, so you just combine them, so you get 4x plus 1x. That's just 5x. So you got 5x plus 1 equals 6. Now we'll just subtract 1 on both sides. And we get 5x equals 5. And then divide both sides by the number in front of the variable. And we get, those 5's cancel out on the left-hand side, so we get 1x equals, well, 5 divided by 5 is 1. So we get 1 on the right-hand side. Okay, so now we know x equals 1. We still got to go back and find y. So you could take that x equals 1, and you could plug it in the top equation right here for x. Or you could substitute x equals 1 in the bottom equation right there for x. It's probably easier to substitute it into the top equation. So what we're going to do then is we have the top equation is y equals x plus 1. And so then we're just going to take that x equals 1 that we found right here, and we're just going to plug that in or substitute that in for x into that top original equation. So if we do that, then we get y is equal to, substituting in the 1, and then plus 1. So I substituted in the 1 for the x. Well, 1 plus 1 is 2, so we get y equals 2. And there you go. There's your solution. X equals 1, y equals 2. But again, they wanted you to write the answer as an ordered pair. So you would write 1, comma 2. All right. Any questions on that one? Well, we're not going to do all of these. Let's try, I don't know what one looks good here. Let's try 3. So number 3. Well, if you look back at those directions at the top, those 5 steps, the first step was to solve either equation for x or y. So you have to solve the top equation for x or y, or you could solve the bottom equation for x or y. What looks easiest? Somebody can unmute. Would you choose to solve the top equation for x, the top equation for y, or the bottom equation for x, or the bottom equation for y? It doesn't matter. I couldn't hear you. You got. I don't know if you can turn your mic up or not. I can barely hear you.
The top, can you hear me?
Yeah, the top for what?
For X.
Good, yeah. Let's solve the top equation for x. Now, you could have solved the bottom equation for x pretty easily also, all right? It doesn't matter. You probably would not want to solve the top equation for y, because if you did that, do you see that you'd end up having to divide by 2? Same thing on the bottom there. You really wouldn't want to solve that one for y. I mean, you could, but to solve the bottom equation for y, you'd have to divide both sides by -1. So we're going to try to keep this as simple as we can. So let's solve the top equation for x. So we want to get this x right here in the top original equation all by itself. So somebody unmute and tell me, how do I solve that top equation for x? Anybody got an idea? I got to solve the top equation for x. So one of you guys can unmute.
Use the bottom x and substitute in the 2y.
Yeah, I could barely hear that.
You would use the x in the bottom equation and substitute the y in the 2y.
Oh no, we're solving the top equation for x. That's what that's what we chose to do. I mean, there's more than one way to do it, but we want to get the x in the top equation all by itself on the left-hand side. So how do I get rid of this positive 2y right here?
Do you subtract the 2y?
Yes. Yep. You subtract the 2y on both sides. Who was that?
Anthony?
Thanks. Okay, here we go. Yeah, we're gonna subtract 2y on both sides on the top equation. So we're gonna go minus 2y on the left-hand side and minus 2y on the right-hand side. The 2y's on the left-hand side are going to cancel out. So the top equation is going to become x equals. Now you can either write negative 2y minus 1, or you can write negative 1 minus 2y, either way. I'll write negative 1 minus 2y. All right, now we're going to take that expression for x, and we have to plug that into the other equation where the x is. So we're going to take this quantity, x is equal to the quantity -1 minus 2y, and we're going to plug that in for x in the other equation. Okay, not back into the same one. So if we do that, the bottom equation is going to look like -1 minus 2y minus y equals 5. But again, if I have a 1 out in front of these parentheses and I have a 1 up there as a power on that quantity, then I don't need those parentheses. I can drop them. I just wanted to put them in there so you could see what I was substituting in for x. Excuse me. So let's drop the parentheses. Okay, so now I can go ahead and solve for y. I have an equation that just has the variable y only in it. So I'm going to combine like terms right here. Both of those y terms are on the left-hand side of the equal sign, so I'm just going to combine them right off the bat. So that gives me -1, and then if I've got -2y, take away 1 more y, that gives me -3y. And that would equal 5. Then I'm just going to add 1 on both sides. And that's going to give me -3y equals 5 plus 1 is 6. Then divide both sides by whatever number is in front of the variable. And I get y equals -2. All right, well now to finish this thing, I need to go back and plug y equals -2. I need to substitute that y equals -2 in and then solve for x. Excuse me. All right, so I could take that y equals -2 and I could substitute it in the top equation for y right there. Or I could substitute it in the bottom equation for y right there. Or probably the easiest way to do it would be to plug it into this one over here. All right, that one is an equivalent form of the original top equation. So I'm going to substitute the y equals -2 in right here, because this equation is already solved for x. So let me do that. So I have the equation x equals -1 minus 2 times y. And I'm going to take my y, this y right here, and I'm going to plug that in right there for that y. So if I do that, then this equation will become x equals -1 minus 2 times -2. And then if I multiply these together, I get x equals -1. I'm going to multiply these. -2 times -2, that's a +4. So that's +4. And then I get x equals -1 plus 4, that's 3. So there's my solution for x. And then I'm going to write my answer as an ordered pair. Remember that the x goes first in the ordered pair. So my solution would be x equals 3, y equals -2. Now remember, if you were to take x equals 3, y equals -2, and you were to plug them in for the x's and y's in both of the original equations, that would make both of those original equations true at the same time. Or if we graph this first equation as a line, and the second equation, if we graph that line, the point where the two lines cross each other, or the point of intersection where they hit each other, would be that point right there, that ordered pair of 3, -2. Let's do one more. Let's do number 5. Let me slide down here a little bit for you guys. That was too far. There we go. So we're going to do number 5. Now somebody unmute and tell me which variable would you solve for? Would you solve the top equation for x or y, or would you solve the bottom equation for x or y? What would be easiest? Anybody got an idea? It doesn't matter what you do. You can pick. You could solve the top equation for x or for y, or you could solve the bottom equation for x or for y. It doesn't matter. Which one would be easiest? Keegan, you got an idea? No response? Aiden, what about you?
Okay, I'm sorry. What did you add?
Anybody got an idea? Come on, we got a whole bunch of you in here. Somebody's got to have an idea.
You would solve for y in the top problem.
Yes, perfect, thank you. Is that Jackie? Thank you, Jackie. Yes, solve the top equation for y. Why would you do that? Well, because it has a 1 in front of that y. Do you guys see that? That right there, that is 1y right here. That's going to be the easiest one to solve for. Because if you try to solve the top equation for x, you're going to end up having to divide by 6. If you solve the bottom equation for x, you'd end up dividing by 3. If you solve the bottom equation for y, you're going to have to divide by 2. So the easiest one to do would be to solve the top equation for y, because all you have to do there is just subtract 6x on both sides. So if you do that, the 6x's will cancel on the left-hand side, and your top equation becomes y equals 11 minus 6x. Now take that expression and substitute it in for y into the other equation. So you're going to take that quantity, 11 minus 6x, and you're going to plug it in for y in the second equation. Well, then your second equation is going to become 3x plus 2 times the quantity 11 minus 6x equals negative 5. Now do you guys see why it was important for me to, when I substitute that quantity in, to put it in parentheses? Because what am I going to have to do with that 2 right there now? Again, somebody unmute and tell me, what am I going to have to do with this 2 right here? Who is that? I can barely hear you.
I said distribute it to the 11.
Yeah, distribute it. Is that Keegan? Thank you. Yeah, so go ahead and distribute that too. So you're going to distribute this positive 2 onto both of these, onto both of those terms. So let's do that. So that gives us 3x. Then we got a positive 2 times a positive 11. That's a positive 22. And then we're going to do a positive 2 times a negative 6x. That's a negative 12x. And then that equals negative 5. And then I'm going to combine like terms over here on the left-hand side. I've got 3x's, take away 12x's. So that gives me negative 9x's plus 22 equals negative 5. Then I'm going to subtract 22 on both sides. And if I do that, then I have negative 9x equals negative 5, take away 22 more, that's a negative 27. Then divide both sides by whatever number's in front of that variable. And we get x equals negative 27 divided by negative 9. That's a positive 3. Okay? So then we've got to go back and find y still. So you could take that x equals 3, and you could plug it into the top equation right here. Or you could plug it in, yeah, that's correct. Or you could plug it in for x in the bottom original equation right there, the second equation. But probably easiest would be to plug it into this one, the one that's already solved for y. So I'm going to take x equals 3, I'm going to plug it in right there. I'm going to substitute it in. That's why this, when I say plug it in or substitute, that's why this is called the substitution method for solving a system of 2 equations with 2 unknowns or with 2 variables. So I'm going to plug the 3 in right there. So that's going to give me here, I'll come over here. That equation is y equals 11 minus 6 times x. And I'm going to take my x that I found, x equals 3, I'm going to plug it in right there. Well, that's going to leave me with then y equals 11 minus 6 times 3, which gives me y equals 11 minus 18. So we get y equals negative 7. All right. So then, and we're supposed to write our answer as an ordered pair. So our ordered pair would be x is 3, comma, y is negative 7. Well, let's do one more problem. Let's set up the story problem. So let me see if I can fit this on the screen for you guys. So the story problem. That's about the best I can do. All right, so the story problem. So it says Kelly is deciding between 2 cell phone plans. The one plan you pay $50 up front and then it costs $20 per month. The second plan you pay $30 up front and then it costs $25 per month. And then the question, there's 3 questions. After how many months will the cost be the same? What will the cost be? And then which plan would be cheaper for a 1-year plan? So let's see if we can set up this system of 2 equations with 2 unknowns. So here we go. So the first plan, it costs you, let's see, the cost. So that's the cost, y, would equal, well, you pay $50 up front plus $20 for each month. And then the second plan, the cost, that one you pay $30 up front plus $25 per month. So let's make a quick note here on what these variables are. So x, and this is going to be hard because I'm right on the bottom of my iPad screen here. X is the number of months. So hopefully you guys can kind of read that. And then the y is the total cost. Okay, well, the first question says, after how many months will the cost be the same? So what we want to do then is we want to, well, this top equation is already solved for y, so we're just going to take this quantity 20x plus 50, and we're going to plug it in for y in the second equation. So if we do that, that will look like 20, hold on. Again, I'm writing right at the bottom of my screen here. So that'll look like 20x plus 50 equals 25x plus 30. Then I'm going to subtract 20x on both sides. And I'm going to get an equation that says 50 equals 25x minus 20x, that's 5x, plus 30. Then I'm going to subtract 30 on both sides, and I'm going to get 20 equals 5x. Divide both sides by the number in front of the variable. I'm going to get 20 divided by 5 is 4, so I get x equals 4. And remember, x was the number of months. So x equals 4 months. So that means after 4 months, the cost of both plans will be the same. Well, then the next question was, well, what would that cost be? Well, that means you can take the x equals 4, and you can plug it either in the top equation right there for x, or you could plug the 4 in or substitute the 4 in for x in the bottom equation. It doesn't matter. So I'll substitute it into the bottom equation. So that's going to be y equals 25 times x is 4 months plus 30. Well, 25 times 4, that's 100. 100 plus 30, that's 130. So that's your cost. So y is your cost. That would be $130. So that's the answer to the second question. So both plans after 4 months would cost $130. And then the last question is, which one would be cheaper if you were going to do a 1-year plan? Well, the first thing you got to remember before you can do that one is that x here represents the number of months. So you got to change 1 year into 12 months. So 1 year, that's 12 months. Okay? Well, we're kind of running out of room here, so let's just see if we can kind of do this. You want to plug 12 months into both of the original equations and see which one's cheaper. So if we plug 12 into this top original equation right here, 20 times 12, that would be 240 plus 50. So that would be $290. If we plug the 12 into the bottom equation for that x, 25 times 12, that is what, 300 plus 30? So that would be $330. So the top plan would be cheaper. So let me write out what that would be real quick. So that would be, you would have y, you would have y equals, it doesn't matter which one I plug it into. I'll put it in the, oh, it does matter because we said the top one was cheaper, right? So we're going to put in 20 times 12 plus 50. So 20 times 12, that's 240 plus 50 is $290. And there you go. Now you've answered all 3 questions. And again, you guys make sure that you, anytime you can unmute your mic and give me a shout out, and I'll stop and answer whatever questions you have. Let me stop the recording here real quick, and then I'll tell you what the assignment is.